Home Skillets of Hardware, it's Prof G, and this CircuitPython school lesson will be all about lists. Creating lists, traversing lists, adding values to lists, and then we'll use our newfound listy skill to create luxurious illuminating lists of light. We'll gain lots of new skills, tips, and techniques along the way, including working with nested loops, so let's light it up list style. So plug in your board, then launch PyCharm, and if you're new to the playlist, here's where you can catch up on the goodness that brought us all to this point. Now let's get into the REPL, open the terminal, up arrow to launch TIO and connect with your board, stop the code with Control-C, press any key, and we see the 3 chevrons of the REPL prompt. And first, let's talk lists. Now, we talked about sequences during our prior lesson when we learned to use an index to address the different lights in a group of NeoPixel. Lists are a type of sequence. Just like all sequences, we access elements of a list using brackets, and like other sequences, lists are 0 indexed, meaning we start counting at 0, the first element in the list is index 0. But there are some things that are special about lists versus other sequences in Python. For example, lists are changeable. We can add or remove elements in a list, and it's even possible to have a list that's empty with 0 elements. And we can also have lists that allow duplicate elements. Not all sequences do that. The text on the right shows a list I've created named family. Family is the variable name. And we create a list setting it equal to square brackets, and inside the brackets, we separate the elements of the list with commas. Now you can access the length of the list by using the len function, the length function, and the length function actually works in any sequence. So len or len, passing in family, produces 4 since there are 4 elements in this list. Now each element is accessed by square brackets and an index value. You've seen this before with elements of the NeoPixel object. Here's an illustration I find helpful. I like to think of a list variable as a box that contains lots of smaller boxes, each box being an element. And here's some examples of using an index. So if we wanted to access element 0, you'd simply refer to the variable name family, and then square brackets would include 0. And if you wanted to access the last element, that would be family passing in 3 between square brackets. That's the last element in a 4-element list. Now, how can we get the last element even if we don't know how long the list is? Well, there are a couple of ways we can do this. If we can get len family, that's the length of the list. In this case, that's 4. There are 4 elements in the list. But remember, our last index in the list isn't 4. 4 is the length of the list, but we're 0 indexed, so we're 3, or we're 1 minus the length of the list. So right here, we want to subtract 1. That gives us 3 in this case. Then we can enclose that result inside of square brackets after the variable name family, and that'll give us the last element in the list regardless of size, as long as there's at least 1 element in the list. And if this looks strange, it's worth pausing or replaying to make sure that you really understand this concept, because nesting values like this, where we get one function or expression that gives us a result, and then we pass that into another expression, is something that you're going to do quite a bit in programming. And there's one more way to get the last element, even if you don't know how long the list is. You can pass in a -1. And what Python does is it goes to the end of the list and subtracts 1, which arrives at the last element. Now, some might say that this last answer is more elegant and Pythonic. It certainly takes up less space. Others would favor the length method because it's more readable. I really think you should know that -1 gets you to the end of the sequence, but make sure you know both techniques. You'll see them both in practice. Now, also know that lists can be made up of any data type. Here are just a few examples. Strings, which we know are groupings of characters between quotes. Python also has several different number data types, including ints, or integers, which are whole numbers without decimals, and floats, that's short for the computing term floating point values, which are numbers with decimal points. And you can also pass in more complex data types. Here we're using colors, which we defined as separate variables. Remember, each one is 3 digits inside of parentheses, and here we're passing in each color using the variable names. Now let's head to the REPL together. You always want to be typing code with me so you can practice what we just saw on the slide. So let's enter the list we had in the slide. Family equals, and list elements are enclosed in square brackets, so open square brackets, and this is a list of strings, so each element is enclosed in double quotes. So that's Homer, comma, Marge, comma, Bart, comma, Lisa, and close square brackets. And if we want to get to the first element in the list, we simply type family, open square bracket, 0, close square bracket, and that returns Homer. And the last element is family, open square bracket, 3, close square bracket, and that returns Lisa. Now family, and in brackets 4, generates an error, index out of range. But remember our tricks for getting the last value regardless of the size of the list. Family, and in square brackets -1, gives you Lisa, because we go to the end of the list and then we subtract 1 element, which brings us to 3, because this is a 4-element list. That'll give us Lisa. Now some of you curious smarties are probably out there doing the chin stroke right now, wondering, what would happen if I typed in -2 between the square brackets? Would it count 2 back from the end of the list? Try it out, amigas and amigos. And as Bart would say, ay caramba, we get Bart. Because Bart is 2 from the end of the list, minus 2 gets us to him, slick. And as we go through and learn new techniques in CircuitPython, you might wonder, hey, can you put your own spin on it and try to get it to do something else? Always give it a try. Writing code won't break your CircuitPython board. The REPL is all about experimentation, and if you try things out in your written code, remember, you can always comment out your working code and then uncomment it later on, and there's always Command-Z or Control-Z to undo any errors. And we can do the same by nesting a function and a little bit of math inside our square brackets to get to the last value. So if we say family and then open square brackets len and then in between parentheses we pass in family, but then once we get the length of family we want to say -1 and then we close square brackets. We're going to do the math where the length family is going to be 4, then we subtract 1, that's going to be 3. That's what we pass between the square brackets, and that also gives us Lisa. Now it's also very common to want to loop through lists. How might you do that, you might wonder? Well, let me show you a few techniques, and you can probably guess at one. You can simply loop through a range which is made up of the length of the list, like this. For I in range, and between parentheses we'll pass in len, and between parentheses the name of our list. Now remember, the range goes up to but never reaches the value passed into the range. So if that value is 4 in this case, since there are 4 elements in the list, then the range is going to start at 0, then go to 1, 2, and 3, but never reach 4. So inside the loop we can print out family in brackets I, and since I is going to iterate from 0 through 3, we're going to print out all 4 members of the family. Now another way to get at each element of the list is to do what's called iterating through the list. Now when we want to iterate through a for loop, we start out with 4, and then we offer a variable name. But this variable is not going to hold an index, it's actually going to hold an entire element of the list. So instead of giving it a name like I or X or index, since this is going to hold a person in the family, I'm going to give it the variable name person. Then just like before, we follow it with the keyword in, but after that we don't have a range. We just enter the name of the list. That's family here, with a colon at the end. Now what this loop is going to do is it's going to extract every element of family one by one with each pass of the list, and it's going to put that element into our variable, which is person. So when this value was an index, it was a number, it was an integer. Now the data that we're storing in here is a string, because this is a list of strings. So inside the loop we can simply print out person, and we're going to print out every member of the family. Very cool. Now there's one more technique I'll show you. This is enumerating on a list. If you wrap the list's name in the enumerate function, that will extract 2 things from each list element. The first is the index number of the element, starting at 0, and the second is the element itself. So instead of having a loop that has one variable before the in keyword, which is either an index value or a variable that will hold an element of the list, when we enumerate through a list, we put 2 variables to the left of the in keyword. The first one is going to hold the index, the second one is going to hold the element. So if I have an index value of I and an element of person, when I enumerate through the list family and I print out I comma person, and you can do that, you can put 2 variables in between parentheses in a print statement separated by a comma, my output is 0 Homer, 1 Marge, 2 Bart, 3 Lisa. Very neat. Now you can do the same thing with a for loop and a range and an index, but some folks think that enumerations are a little cleaner to read. Know all of these techniques. Sometimes one is a better choice than another, and for my students, I might ask you to demonstrate all techniques on a future test. Ooh. Now let's head to the REPL and make sure that you can try out the goodness and be prepared for challenges. So first, let's loop through the family members with a range that uses the length of the family list. We'll say for I in range, in parentheses len, open parentheses family, then close parenthesis, colon, and remember when you press return, after entering any kind of statement where there should be lines indented below it, you're indented and you get 3 dots instead of the 3 chevrons. And by the way, if you ever make a mistake here, you can Control-C to get out. Then you have to re-enter the entire loop, unfortunately. I'll just up arrow here so you can see me get back into the loop. But while we're indented, I'll say print, in parentheses, family, square brackets, I, close square bracket, close parenthesis. We only have one line here, so we're done. So we'll press return. Delete will get us out of the area where we're indented in our REPL. Then we can press return. Our code executes. We see all 4 family members. Nice. Now let's try iterating through the list. That loop is going to be for person. Remember, we could use any variable name, but I've chosen person here because each element of a family is a person. Then the keyword in, followed by the name of the list, family, no range here, colon, press return, and to print out on this line, we'll simply say print, passing in between parentheses person, press return, delete return, and our code runs and we see all family members. Nice! Now with enumeration. For, and here we want two variables. Remember, our first one is an index, we'll call that I, comma, the second one is going to hold an element of the array, so we'll call this person. We need the in keyword, and then we'll follow this with the enumerate function, and between parentheses, we pass in the name of our list, which is family. Close it with a colon, return, and let's print out both variables, so we'll say print, and between parentheses, I, comma, person, press return, delete, return, and we see 0 Homer, 1 Marge, 2 Bart, 3 Lisa. And just to point this out, as we'd said previously, you can get the same results with a range of the list length, so why don't we try that? For I in range, open parens, len, open parens, the name of our list, which is family, close parens twice, colon, and when we press return here, we can say print, and in between parentheses, I, comma, then family, and between square brackets, I here, closing square bracket, closing paren, return, delete return, and we see the same results with the range and the length function. In your own code, it's up to you whether you want to use enumerate or whether you want to use the two functions range and len together. They do the same thing. I want my students to know both techniques. So this is cool. But now some of you might be wondering, hey, Prof G, it looks like you're making a mistake here. Don't you know the TV program family on which you've based your family has one more member? Oh yes, The Simpsons have baby Maggie. How can we add her to the list? Well, my friends, we've got a special function that we can apply to any list. Remember, I said one of the features of Python lists was that they were changeable. You could add or delete elements in a list. To add Maggie to the end, we'll simply say family.append, and between parentheses, we'll pass in the string Maggie. Now let's make sure she's in there. For person in family colon return, print in parentheses person, return, delete, return. And look at that, Maggie now lives there in the family, and we can len in parentheses family. We see The Simpsons now has 5 family members. Now, some of you might be wondering, Prof G, where can I find out the functions that I can apply to, say, a list value? Well, my friends, the Python REPL has a very cool help feature. If we type the word help, then between parentheses pass in the name of a value, like, for example, our family variable, then press return, we'll get a list of different functions that we can access with dot notation that can work on a list of strings. Look at that! And if you want to learn more, there's all sorts of online Python documentation. You could just search on any of these function names. We've also seen that PyCharm can offer up information on different commands. But this is a great start. Now enough of the REPL. Let's exit out of here and write some code to light up our NeoPixels with our newly acquired list-tacular knowledge. We'll Control-D to exit the REPL, and to give us more room, why don't we close the terminal? And one more bonus tip to give yourself even more room, if you go up here to the upper left-hand corner and click on the folder, it acts as a toggle which will show or hide the project sidebar. Now when we tackle a challenge, we're going to leverage code that we wrote in the prior lesson, which is lights-out-and-back.py, and we're actually going to use lines 1 through 17 that you see here. So if you're new, you can enter these lines of code now. The first challenge is Flash the Rainbow. Build a list named rainbow_colors where every element is a Roy G. Biv color. Leave out white and black. The list at this point should have 7 colors. Then create a new color named cyan, which has the RGB value 0, 255, 255. Use a function demonstrated in the lesson to add cyan to the rainbow colors. That should give you 8 colors in the rainbow colors list. Then loop through all 8 colors, flashing all lights at once, looping through each color for half a second. Repeat the flashing forever, and save as flash-the-rainbow.py. So pause, Pythonista, give this a shot. Rewind the video if you need help on any of these techniques. And when you're ready, resume, and let's compare answers. So let's change the comment to flash-the-rainbow.py. Delete everything below the time interval, and since we're going to flash for half a second, change the time interval to 0.5 seconds. Now part 1 is to create a rainbow colors list. So we'll name that rainbow_colors and set it equal to, in between square brackets, red, orange, yellow, green, blue, indigo, violet. Part 2 is to define cyan, so in all caps cyan equals, and between parentheses, 0, 255, 255. Part 3 is to add cyan to the rainbow colors list, and to do that we use our good buddy the append function. Rainbow_colors.append in parentheses passing in cyan. By the way, when we have functions attached to different objects like this, for example, the append function is attached to lists, we call those methods. Methods are just functions that are attached to objects. You'll hear both terms used. All methods are functions, not all functions are methods. And in an upcoming lesson, you'll learn how to define your own functions. Now to get flashy, for part number 4, we're going to loop and flash, and I'm going to choose to do this through iterating through the list. So we'll say for rainbow color, singular, in rainbow colors, plural. Colon. Now when we iterate on a list, we just pass the list at the end of the for statement, and that goes through every element of the list. Now we could have named our variable here rainbow color anything, but it's often good practice to name your list with a plural and name the variable that you're putting each individual singular iteration into as a singular. Then down below we'll say pixels.fill in parentheses passing in rainbow_color singular, because with each pass of rainbow colors, this rainbow color variable will hold the next color that's in our list. Then we'll time.sleep passing in time_interval, and there's one more thing we need to do. Part 5 is repeat forever, and to do that we use our while true loop. While space capital T true, colon, and then we need to indent all of these lines that are underneath true to make sure that they repeat forever. So what I'm going to do is I'm going to highlight all of them and press the tab key. When you highlight a block of text and press tab, you indent. If you press shift tab, you outdent. That's it, Flashmasters. Let's click on terminal so we can see our results. I'm already running in TIO. If you're not, make sure that you get into TIO. I'll go up here and click save. Usually takes a second to start. And look at that, we're getting flashy over and over again. If you count the colors from red, you can see half a second at a time. We're going through all of them. Roy G. Biv plus cyan. Good work! And if some of you are wondering, hey, Prof G, could we use a range based on the length of the rainbow colors list? And as they say in Espanol, si se puede, yes we can. And here's an example of what that code would look like. I'm going to close up my terminal, and I'm going to save this file to my CircuitPython folder, flash the rainbow.py, close up that new tab, and make sure that you're back at your code.py tab on your CircuitPy volume. Now, smarties, let's see you rock the Loop the Rainbow challenge. You're going to use the 7-value rainbow_colors list that you just created, and you're going to loop through all of those colors one at a time. And for each color, you're going to loop through all of the NeoPixel lights on your board, lighting each NeoPixel in the current color one at a time, waiting 0.1 seconds between each light. The effect is seeing a single color loop around to fill all the lights in the CircuitPlayground. And when the CircuitPlayground is filled with one color, keep the lights on, but move on to the next color with the same animation. The effect will show the prior color being replaced one light at a time with the new color. That should be repeated for all the rainbow colors, then restart from the first color and loop forever. When completed properly, you should see fabulousness similar to this example. Then save this when you're done as looptherainbow.py. So pause and release the power of that massive brain of yours. I know you can do it. Review the lesson if you need to. And when you're ready, resume and let's compare answers. So let's change our top comment to loop the rainbow, and we'll change our time interval to 0.1. I'm going to cut out this part 1 comment because that's no longer part of the challenge, because we already did it. And we can delete everything underneath rainbow colors. Now the new part 1 is to loop through all of the colors, and you know how to do that. You can use different techniques, but I'm going to iterate. I'll say for rainbow_color, singular, in rainbow_colors, plural, colon. Now once we get a color, what are we supposed to do? Part 2 is loop through all of the NeoPixel lights, lighting them in the rainbow color. So we're going to say for I in range, in parentheses, len, in parentheses, pixels, colon. Now, unfortunately, you can't say for pixel in pixels. You can't iterate on pixels. What that does is if you try it out, it extracts the 3-number color. It doesn't point us to a pixel that we can edit. So we've got to go through the range of the length of pixels, but then below we'll say pixels in square bracket, I, giving it the value equal to rainbow_color, which is our outermost loop. Then we time.sleep, passing in time_interval, and it's worth taking a second to explain what's going on here. When we have one loop inside of another loop, we refer to this as nested loops. So we've got our rainbow color list, and then our outer loop. So the first time we go through this loop, rainbow_color is going to be red. With the rainbow color as red, we hit the inner loop, the nested loop, and this takes us through all of our pixels, and there are 10 of them, so the range is 0 to 9, so I starts at 0, with pixels bracket 0 turning red. Then we wait for the time interval, then we continue the inner loop, not the outer loop. The second pass of the inner loop has I equal to 1, so we let up pixels 1 in red. Then we continue 2 through 9, lighting up all of those lights in red. And after 9, we wait, then the inner loop is done. We've gone through it 10 times, which is the length of our range, so we move back out to the outer loop, and we get the next color, which is orange. And then we restart the inner loop from 0, setting pixel 0 to orange, writing over the previous color that was red, then pixel 1 to orange, all the way through to pixels 9 being orange, then we hit the outer loop again, the next color would be yellow, we continue the pattern until we've gone through all of the rainbow colors, and after that, the only thing left to do is to repeat forever, and you know how to do that, with an infinite loop, our buddy while true. I wrote part 4 in here, it's really part 3, but it's loop forever. That's just while space true, capital T, colon. The yellow here is PyCharm's warning saying, hey, if you've got a while true loop, you've got to indent the stuff below it. Highlight both loops below this, tab out so they're indented below while true, and my friend, you've got your code. Let's open the terminal with Tio running and experience the goodness. Click up top and save, and in a second, oh, look at that magnificence. You can see we're going through all of the lights in our pixels object, and after we've gone through all of them, we switch to the next color, so we go through all of the colors in our colors list. Nice work! Make sure you save this as Loop the Rainbow this time, get that in your CircuitPython school folder, and close up that outer tab, and be proud of your big learning. We learned all about lists, creating lists, referencing list elements, and we learned many ways to traverse lists, including using a range of the length of a list, iterating through elements of a list, enumeration, which gives us 2 values, an index and an element of a list, and we used nested loops in our challenge. We learned to use the append function to add values to a list, and we learned about the help feature and lots of tricks and tips. But even more importantly, you conquered challenges, flash the rainbow, and loop the rainbow. Your list and light skills are now legendary, use them to make some awesome, and be sure to come back for more big learning.